Hey gang, so apparently my SQL and relational data modeling lesson sound went out, so we're going to give this a take two. Let's talk about databases, specifically relational databases. So let's say we're trying to keep data on some kind of relationship. So we might have something like book and something like author. So in our situation, let's say that one author can have a bunch of books. Every book is only by one author. Now, keep in mind that this is specific to whatever kind of problem that we're trying to solve. It's not reality. In reality, one author can write a bunch of books. It could be each book can have a bunch of authors. For that matter, let's say all we ever store is autobiographies. Well, then maybe it's a one-to-one thing because a book and their author kind of refer to the same data. We always need to consider this in the context of the problem we're solving, not just however it is in real life. So this relationship should be one author has many books. And if we read this backwards, it's not many books have one author. That's just the same thing the other way around. So we'd say one author has many books, and each book only has one author. So if we do it that way, we go, okay, maybe the author has an ID. So this is marked as PK, means primary key. A primary key is something that uniquely identifies every record. So you can make primary keys out of all kinds of things, like the author's social security number or something like that, anything that could be unique. However, keep in mind, like 99 times out of 100, having something that doesn't have anything to do with the actual data is a way safer key. Because if you, let's say you do their name, okay, well, more than one author can have the same name. Yeah, okay, what if it's some other kind of unique identifier? Okay, well then that changes. Social Security, they get a different social security number. They go by their EIN instead, something like that. That data changes. Everything that's related to that data needs to change also. And that's where we start getting spooked. So having what we call in the business a surrogate key, something that its only function is serving to uniquely identify that record, that's usually a good choice. Also, notice that the this isn't a class diagram. This is a schema diagram, an ERD, entity relationship diagram. These are entities, these are relationships. So they kind of look similar, and they get used in many of the same kinds of situations as far as modeling data goes, but technically a different diagram. So we have the name of the database table, not a class, database table. This big area over here keeps the name of the column. This thing over here is for any kinds of keys that we want to identify. Every once in a while, you'll see another column over here that identifies what the data type is. That's a true schema diagram, doing it that way. A lot of times, we just leave that part off. So for our model, let's say books have titles and authors have names. Cool. So when we're trying to figure out how to store the relationship between these things, in relational databases, we do it flat. In object-oriented stuff, like let's say we had a book class and an author class. In this situation, a book would have its author as one of the properties on the object. So when you get Great Expectations or Grapes of Wrath or something like that. You have the Grapes of Wrath object. There's going to be an author property on that that's equal to the John Steinbeck object because he's the author of Grapes of Wrath. So this you can kind of think of those relationships as like almost nesting inside of each other. So this is the book, and then this is the author. There's a reference to it inside of the bigger thing. In databases, we need a way to store that flat. We can't store things inside of each other. So if we're having these two things completely separate, how do they know about each other? And the way that we do that is with foreign keys. So a book might have an author ID that's a foreign key. It's really easy to overcomplicate what a foreign key is. It's just another table's primary key. So author has an ID, that's its primary key. Any other table that needs to reference this ID does it as a foreign key. Primary key, foreign key. And the convention on it is generally name of the table underscore ID. So let's take a look at what some actual records that we made this way would look like. So author might be ID of 1, name is John Steinbeck. Might have another record for me, another one for Oscar Wilde. So like we can keep making records like that. So over on the book side, maybe we have ID of 1 of mice and men. And then this foreign key is going to be the ID of that author. So just put a 1 there. Our second book, Grapes of Wrath. Also, foreign key is 1 because it's pointing to John Steinbeck. Let's see. Let's say that I wrote a book called How to Program. So my ID in this table is 2. So that's the foreign key. Ta-da! That's it. So we store these integers, or whatever the ID is, like it's a UUID or whatever. We store a little reference to that, but it's not magical. It just needs to be the same data type and the same value as whatever we're trying to match to. And then with the database, we can use that ID to make the association and look up anything that we need. Anything we need to. Sorry. All right, so let's see what this looks like in code. So if I go into this SQLite practice thing, okay, so if I want to make a new database, I can use the SQLite 3 command or whatever SQLite you installed. The one that comes in from npm is SQLite 3. And I can say SQLite bookstore.db. I think I mentioned this on another thing. The extensions don't mean anything. They're just characters. It works just as well if you do that. But that gives us some hint of what's being stored in there, so that helps. All right, and then once you're in SQLite, if you need to get out of SQLite, Command D will do it. It's Command even on Mac. Command D will get you out. Also, .exit will get you out as well. And then if you forget any of that, they tried to help you out. Right at the top, this .help. These are all the things that you can do. So, all right, cool. So let's say I want to make this data model that we just made. So we need to create the tables. You generally want the one without any foreign keys. That's the stuff that you want to make first. So Our author table, the format for a create table statement is create table, and then whatever the name of the table is. And then you open up some parens, and then it's going to be the name of the column name, whatever the data type for that is, so int or whatever, and any keywords that go along with that, primary key or whatever. The only ones you need to worry about right now as far as like data types go is there's int varchar, which is, it's kind of like a string, but you need to give that a size. If you don't know, like names are a great example. If you don't know, but it's not really that long, then 255 is a good default for that. It's way better than picking 10, and then you get somebody with a name with 12 characters in it, and like you can't store it in your database. So if it's not that big, like a city name or a person's name or the name of a program or something like that, 255 is a perfectly fine default. If it's arbitrarily long, like a blog post or something like that, that's text. And then Boolean is true or false. Those are the only 3 data types you know how to use in SQL. You'll get by just fine. Cool. And then you end it with that and a semicolon. Semicolon is important. It's not optional in SQL. It will not run if you don't do it. And this actually comes in handy when we're writing out these queries. So fire up that database again. So I want to create a table called author. And let's see, author had ID and name. So ID is going to be an integer, and it is a primary key. SQL, you can't auto increment things in SQLite, so that'll have to do for us. We'll have to manually enter in the IDs when we make them, but in a production database, the database kind of handles the auto incrementing part for you. All right, so we've got that, and then we have name, which is varchar 255. So you might notice that I'm using capital letters for like the keywords, lowercase letters for stuff that's specific to what I'm making, and that's intentional. That's like the convention in SQL. We capitalize stuff that's part of the language. We don't capitalize stuff that's not part of the language. Helps us the syntax stick out a little bit more. Okay, so then I close that up. Cool, done. I can, if I want to check that that actually worked, you can do .schema. It's another handy command in it. It'll fire back all of the create table statements that have been run. All right, and then the other one is going to be the book table. So this one will be create table book. Oh, another note on that. This one is a little bit more controversial. I don't think it should be, but it is. Table names, singular. Use singular. Kind of counterintuitive. It seems like, hey, well, it stores many authors. It stores many books. Shouldn't it be plural? And it starts getting awkward when you are writing join statements, when you're doing things with it, because you're really referring to a specific like singular record in this. When you're writing a join statement, you want to say like, well, when author ID is the same as author.id is the same as book.author ID. Those should match up. Authors.id, books.author ID doesn't really work. So when you're using it in practice, it makes way more sense to do it singular. So that's what I encourage you to do for your database tables as well. All right, so this one had starts the same way, had a primary key, had a title, and also had an author ID. So the keyword that we want to use on this is also an integer, and it references. So that's how we create a foreign key in SQL. Say references, and then the name of the table, and it's kind of like a function. What column on that table does it reference? And then close it up. Pew! If I run .schema, I should have both of them in there. And I do. Cool. So we have the schema for this database in there. Now we also need to put some stuff in. So the way that we add data to a table in SQL is with insert into table name. And then you want to put whatever properties are being added. So properties, I guess, let me stay consistent on language, column names. Columns go here. And then you use the keyword values open up parens, and then everything after that is each new record we want to insert, surrounded by parentheses, separated by commas, like so. So, and these are comma separated, whatever. So some things worth noting. If you're going to put in some characters, single quotes. SQL, the different kinds of quotes, single quote, double quote, backtick, they all mean different things. So you're just trying to insert some string somewhere. That's a single quote. All right, let's do it. So if I insert into author, ID and name, values, and open that up, then it's going to be looking for an ID and name. And then the way that you add more records, it's like that. Another thing to note, so when I first started writing this, SQLite is over on the left. That's the beginning of a new statement. When you see this thing, that means you're in the middle of some previous statement. Really common issue when people are getting started with SQLite is they'll start a SQL statement, but they never actually finished their previous one, but usually because they didn't put a semicolon on it. So they're still actually in that first statement. But it'll keep letting you hit enter until it sees a semicolon. That's the only way it knows to stop. So I can enter John Steinbeck and Kyle Corbally. And then finish that up. Awesome. So now if I try getting stuff out of that author table, hey, there we both are. I can do the same thing with book ID, title, author ID, like so. So this might be 1 Grapes of Wrath. Author ID is 1. And then 2 is of Mice and Men, also 1. And How to Program by Kyle, and I'm 2. So I do that. Now those are in there. Cool, show me every book. Select all from book. All right, and there they all are. So next kind of thing. Now we need to be able to write something that like actually gets these values back out. So the format of that is basically has 3 parts. The select clause, what do you want to see in the result. That's all that part of it does. From what data do you need to acquire it? And then the last part, what should be left out? Even like fairly complicated SQL statements, it's basically those three parts: select clause, from clause, where clause. So for example, if I want to get all books, select all from book. Cool, gives me all the books back. Let me see, let's say I just want the titles for that. Select title from book. Cool, just shows the titles. If like a query comes in, like a URL query, show me book 1, show me book 2. So I could say select title from book where ID equals 2. And it just shows me that one. Okay, so now I think the trickiest thing you have to do in the assignment this week is joins. The whole point of this was that if I want to get of mice and men and the author info, how do I use that relationship in the database? Well, select, you can even qualify this. You can say like book.title, author.name from, and then either one. This is one of the cool things about from clauses. Doesn't matter what order you do these in. From book, inner join author. So what that's looking for is what columns are the same on the two tables I'm trying to relate. So I want to join author on author.id equals book.authorid. Also, order on that doesn't matter. I could have done from author inner join book on book.authorid equals authorid, or any different combination of that. It really doesn't matter. And then I can still do where clauses. I can say like where ID equals 2. Oh, because they both have IDs. Try that again. Select book.title, author.name from, here, I'll just to show that it works. Author, inner join, book on book.authorid equals author.id, where book.id equals 2. Of mice and men, John Steinbeck. That's how you query relationships in SQL. And like, I'll tell you, there's like, there's more to SQL. There's aggregates and subqueries and all kinds of cool stuff. If you can do all of these things, that's the SQL that like 99% of people like have ready to go in memory. If like as a software developer, that's kind of what you know about SQL, that gets you by. That gets you pretty far. Cool. So hopefully that's helpful. Good luck on your assignments this week. Oh, one more thing. Actually running this stuff. So we've got this this DB file here. It's a little bit awkward to type these out in the SQLite interface all the time. So you could make something called like queries.sql, and you can write all your stuff out in here. So if you did select book.title author.name from book inner join author on book.id, book.authorid equals author.id, where book dot ID equals 1. So let's say I write a query like that. If I want to run that on the database, bookstore.db, and then use this redirect operator, little angle bracket, and then the name of the file. That uses the contents of that file as an input to this like database command. Oops, I gotta tell it to use pSQL, or sorry, SQLite. So the SQLite command in this database, use all the stuff in queries.sql as an input, and then it runs it for us. It's pretty cool, right? Now, to save you some like awkward, you may have noticed, it's kind of hard to copy and paste stuff out of a terminal. So we got a way to help us with that too. If I put all of that stuff in parentheses, it's like math. We're treating that as one expression, and I want to take the output of that and send it to a file. I can use the other redirect operator to say, take the output of this and put it in like results.txt. And now when I open up txt, results.txt, hey, there's the stuff from my queries. You can have more than one query in the same file, and you can just pipe all of the output of that straight into the file with those redirects. Kind of cool, right? So good luck on your assignment this week. Sorry the first video got messed up. Hopefully this one comes out a little bit better. All right, cheers.